Hello and welcome to video series of current electricity for IIT JEE or NEET physics. So in this very first lecture we are going to discuss about strength of electric current. Okay. So current electricity is one of the very important concept for IIT JEE or NEET physics. So, so let us see what is in the present lecture. So in this very first lecture I am going to discuss about strength of electric current and its definition, formula, units, instrument used to measure, and definition of ampere as well as dimensional formula. After that, I'm going to explain about applications of electric current, like finding current, finding amount of charge crossed, and IT graphs, and charge and time graph, as well as current due to translatory motion of charges. So current due to rotatory charges. So after finishing this, we will discuss about current density. Okay. So without any wasting of further time, so let's dive into the video lecture. So what is electric current? So in olden days, the human is living in caves like forest or whatever it may be. So in that case, we observe. So in olden days, or even now also we can observe. So clouds when you contact with some trees, long trees, they observe it is getting fired. It is getting fired. Okay. So when here to explain this phenomena, this is what we call lightning. To explain this phenomena, we are studying. We are taking it as some charges. Some the cloud is having some charge. Okay. So the cloud is having some charge. The charge is discharging through this tree. When it is discharging through this tree, what is happening? Some energy is dissipated in this tree. So here, what is happening by the motion of these charges? So by the motion of these charges, some energy is delivering in the form of electricity. So this is nothing but we are calling it as electric current. So electric current means it is the rate of flow of charges. The rate of flow of charges through a cross section, through an area of cross section. Okay, through an area of cross section. That means the charge, how fast it is discharging through an area of cross section, or how fast it is moving the charge. Okay, so the current formula is I equals to q by t, where q is the charge, amount of charge crossed by time taken. Time taken. So here the unit for the electric current is ampere. Ampere. So its symbol is capital A, which is named after a scientist. So we have some rules for writing SI system of units. So according to that, the units symbols named after a scientist should be written in capital A. So we have taken capital A. As well as we can write the unit for charge current is coulomb by second. Okay. Second, coulomb is also named after a scientist. So capital C by second. Okay. Coulomb, second inverse. And electric current is a fundamental physical quantity. Fundamental physical quantity. Fundamental physical quantity. Hence, It is a fundamental physical quantity. It has a dimensional formula capital A, capital A. Okay, as well as we can sometime uh, written it as capital I also we can write. Now let us define ampere. So let us define ampere. So 1 ampere, which is a unit for current, it is given by 1 coulomb by 1 second. 1 second. That means if we take some area of cross section, through this area of cross section, if 1 coulomb of charge is crossed in 1 second, then the current is 1 ampere. Okay, so the ampere means it is the electric current when 1 coulomb of charge is delivered or cross any area of cross section in 1 second. Okay, so and the device instrument that is used to measure electric current is ammeter. Ammeter. So ammeter is used to measure electric current. Okay, and sometimes we also use galvanometer to measure electric current. Galvanometer and ammeter measures current only, but galvanometer is very sensitive. So in general, it is used to measure low current. Okay. So after this, let us discuss about some applications of electric current. First one, there is four ways of possible ways of answering. I mean, getting questions from electric current. So first thing based on uh, I equals to Q by T. So if in questions, if they ask, they give some charge and time taken for the charge to cross some area of cross section, then by substituting in this formula, we can find electric current. Okay, so electric current equals to charge crossed by time taken. Okay, so by simply substituting the values here, you will get current. And another one, again from very this formula, Q I can write it as I into T. So if you have current and time, if you have current and the amount of time taken for the current to flow, by using this you can find how much charge is crossed through that area of cross section. Okay, after that, and these two cases applicable when current is constant. Okay, and one more case is we have, if suppose current is a function of time. Okay, current is a function of time. So in this case, how to find the amount of charge? Amount of charge. So it is better to write like this. So Q equals to integral I into dt. That means by taking integration of the current, we can find amount of charge crossed in this particular time. Suppose the time limits are from t1 to t2. Okay, suppose if he is asking to find the electric charge crossed between t1 and t2 time. Okay, so for that we can use this formula. And suppose if you have current and time graph, current and time graph like this. Now he's asking to find how much charge is crossed between intervals t1 t2. Okay, so he's asking to find how much charge is crossed between these interval. So it is simply to find this, simply we can integrate. Okay, so actually integration is nothing but area under the curve. Okay, so from the graph also we can find how much current is, I mean how much charge is crossed. So in this case, we cannot find area easily, but if current is like a straight line, now is asking how much charge is crossed between the time interval t1 and t2. So in this case, by simply finding the area under the curve, we can find how much charge is crossed. Okay, we can find how much charge is crossed. So here one more thing we can write, q equals to area under current and time graph. Okay, so one more possibility, one more thing I can get, how much current is there. If q is a function of time, q is a function of time, in that case we need to apply differentiation. Okay, so in this case the amount of charge crossed is depends on time. The current, I mean the amount of charge is not a constant, it is depends on time. Okay, in that case to find the electric current, simply we can take differentiation. Suppose we have a graph between amount of charge crossed with respect to time. Okay, suppose the graph is like this. So that means at time 0, at initial time 0, the amount of charge crossed is 0. If time is passing on, the amount of charge is also varying. Okay, in this case to find the electric current for I mean at a particular instant, so simply by taking the slope of the tangent, at this point, okay, slope of the tangent at this point, you will get how much current is there at that time. So it is nothing but by taking the differentiation of the function, we can get amount of electric current. Okay, so in a, if charge is as a function of time and the graph is like a straight line, in this case the slope of the graph dq by dt is constant, but slope of the graph here dq by dt indicates current which is a constant. Okay, so in this case, suppose at time t1 the amount of charge crossing is q1. So at another time t2 the amount of charge crossed is q2. Now I want to find how much current is there. So for that, current equals to delta q by delta t, where delta q is the change in, I mean, how much charge is crossed between the two intervals. So in this case, q2 minus q1, and delta t is the time taken, that is t2 minus t1. Okay, so by substituting these values, we can get uh, amount of current. Okay, now one more application we need to see. Current due to translatory charges, translatory motion of charges. Okay, suppose I have taken n number of charge carriers of charge q1 is crossing some area of cross section from left to right. Okay, and n2 charge carriers are crossing from right to left. Okay, so now let us consider both are of positive charges only. So here the current direction will be generally from positive, for positive charges. for positive charges, the current direction also in the direction of motion of the charges. Here we have taken both are positive charges. So the current due to the Q1 charges will be from left to right. And for N2, Q2 charges. So here Q2 also positive I have taken. So in this case also current will be in the direction of Q2 only, that is I2. Okay. If you carefully observe, the current are in opposite directions. So the net current will be I1 minus I2. Suppose N1 is greater than N2. Okay. Here I1 is greater. So I1 minus I2 I have taken. If N2 is more, N2 is more. Okay. So in that case, uh, we will consider I2 minus I1. Okay. No need to worry about the sign of the electric current. So, but here I1 means the amount of electric, I mean strength of the current due to the Q1 charges. Okay. I am taking the time taken to cross is delta t only, or simply t. Now what happened? I1 equals to amount of charge N1 Q1 minus I2 means N2 Q2 by time taken is t. Is t. Okay. So here I equals to, I can take mm, so one more thing here, let me take one condition here. So here we got I equals to N1 Q1 minus N2 Q2 by T. Okay. Suppose Q1 equals to Q2, case 1 I have taken E. Okay. So I have taken some protons are carrying, protons are moving. In this case, what happened? I equals to N1 E minus N2 E by T. This gives N1 minus N2 E by T. Suppose Q1 equals to Q2 equals to minus E. And then what happened? Here N1 minus N2 into minus E by T. Here already we have taken N1 is greater than N2. So this is positive value. Here minus E is negative value. So current is, we are getting negative value. That means actually here resultant current is from left to right we have taken. I1 is greater, that's why. So, but in this case, what happened? We are getting negative value. That means current is not from left to right, but it is from right to left. Right to left. Okay. So that's why the symbol is important. And suppose Q1 equals to E and Q2 equals to minus E. In this case, what happened? Here we have taken uh, protons are moving from left to right, electrons are moving from right to left. So opposite charges we have taken. In this case, I equals to uh, N1 Q1 is E only minus N2 Q2 is minus E by time t. This gives N1 plus N2 E by T. That means here if N1 protons are moving from left to right, N2 electrons are moving from right to left. The resultant current I will be N1 plus N2 E by T. Okay. Why? Because The current due to the electrons is opposite to the direction of motion of the electrons. So here the electrons are moving from left to right to left means current will be from left to right. That means I1 and I2 both will be in same direction. That's why we are getting positive. Okay. And after this, we need to discuss about electric current due to electric current due to electric current due to rotatory charges. Rotatory charges. Suppose I have taken hydrogen atom. Hydrogen atom I have taken. The hydrogen atom will have positive proton in it. Around this positive proton, one electron will rotate in circular path. Okay. So in circular path, the electron is rotating. Let us take the radius of the circle is capital R. Now I want to find actually here also electron is having charge. The charge is moving. So due to the motion of the charge, we know the electric current will produces. So here, suppose the electron is revolving in anti-clockwise, the current will be in clockwise direction. Now I want to find the how much current is occurring. Okay, how much current is arising from the motion of these charges, motion of the electron in the, for example, in hydrogen atom. Let us see how it is. Suppose here, let us take the electron is taking capital T time to move from here to and come back to here. So if it is started here to come back to its initial position, it is taking capital T. It is nothing but time period. Time period. Okay. So now I want to find the electric current. Electric current we know I equals to charge here electron charge E by time taken T. But here I am taking time capital T. So electric current equals to E by capital T. Let us do one thing here. Let me take generalized case. Generalized case with some charge Q. Some charge Q. Okay. So what happened here? It will be Q by T. Q by T. Amount of charge by time taken. So it is nothing but Q into frequency because 1 by time period means frequency. Now let us find what is this T value. If you know the time period, we can find the amount of, the strength of the electric current. So for that, let us take the charge is moving with the speed V. Okay. So with the V speed, it is actually traveling 2 pi r distance. 2 pi r distance. For that, it is taking time capital T. So V equals to 2 pi r by T. So this gives T equals to, sorry, 1 by T equals to, so 1 by T equals to, see 1 by T to, sorry, 1 by T equals to V by 2 pi r. So now replace here it is I equals to Q by T here. Q by T means Q V by 2 pi r. Okay. So this is the electric current due to moving charges. Now in case of angular velocity or angular frequency, you know V equals to r omega. Okay. So again I can write this equation I equals to V equals to R omega, right? So from this V by R equals to omega. So V by R equals to omega. That means I equals to Q omega by 2 pi. Okay. So here this is angular velocity or angular frequency also we can take. Okay. So now let us discuss about electric current density. So electric current means it is the amount of charge crossing through any area of cross section in a given interval of time. Simply it is the rate of flow of charge through any area of cross section. But current density means it is the rate of rate of flow of charge through unit area of cross section. The unit area of cross section. Okay. So it is nothing but current through unit area. Unit area. Okay. So here J equals to current by area or nothing but I equals to J into A. Actually, electric current is a scalar, but here J current density is a vector quantity. Vector quantity. And suppose I have taken a conductor. I have taken a conductor. Okay. So I have taken some area of cross section like this. I have taken this area of cross section. Through this, the current density is J. J bar I have taken. So now I want to find how much current is in this particular direction. Okay. So I have taken small area of cross section like this, and the direction of the area vector will be always perpendicularly outward or normally outward to the surface. So this is A bar direction, and here J bar is like this. Now here we can observe A bar is like this, J bar is like this. Between these two I have taken the angle is theta. Now I want to find how much current is flowing across this area of cross section. Okay, the slanted area of cross section. So let us find it. So actually I equals to integral J bar dot A bar. Okay, but here J bar dot dA bar actually we have to take. So integral J bar dot dA bar. So now this is equals to J A cos theta. Okay, for J is current density which is constant I have taken. In this case I can simply write it as J A cos theta. Okay, so current equals to J A cos theta. This is the current of passing through this area of cross section, not perpendicular to this, not perpendicular to the current density. So I have taken with some angle. Okay, like this we have taken. Now I want to find how much charge is crossing this unit area. Okay, or how much current is passing through this area of cross section. So that is given by I equals to J cos theta. Okay, suppose theta equals to 90 degrees. That means suppose current density is like this. Okay, I have taken the conductor. Inside the conductor current is flowing along the wire. Now I have taken some area of cross section like this. Okay, here the current passing perpendicular to the length of the wire is 0 because theta equals to 90 degrees. That means I equals to 0. Okay. So again, let me explain again this one. So actually, I have taken the conductor. So inside this conductor, the electrons will move in random directions. So if you consider current density is along the length of the conductor. Now to find how much current is passing, okay, not only perpendicular to the length of the wire, and also suppose I have taken this area of cross section. Now in order to find the electric current, we simply use J cos theta. If we take the surface perpendicular to the current density like this, okay. So here what happened? Area vector is like this. Current density is horizontal. That means the angle between J bar and A bar is theta. That is 90 degrees. So cos 90 is 0. That's why current is 0. That means no charges will cross perpendicular to the current density. I mean net resultant charge crossing through this area of cross section will be 0. Okay. Suppose theta equals to 0 degrees, then I equals to J into A, which is maximum. Suppose here if you consider a surface perpendicular to the current density, here area vector and current density both are in same direction, theta equals to 0 degrees, so current will be maximum. Okay, so I hope everyone you understand this lecture clearly. So again, let me give quick summary. So current means rate of flow of charge, rate of flow of charge through any area of cross section, and its unit we know. Here formula is I equals to Q by T, and from this Q equals to I into T. If current and charge are time dependent variables, then I equals to dq by dt. It is nothing but slope of qt graph, charge and time graph, and q equals to integral I dt. It is nothing but area of current and time graph. Okay, so after that we calculated, we derived an expression for the current due to translator charges. Okay, so there we got n1 minus n2 E by T. Suppose n1 protons are moving from left to right, n2 protons are moving from right to left through some area of cross section, then the net current will be this one. Here n1 is greater than n2, and after this we derived an expression for current due to a rotator charge. So I equals to Q into F or Q by T. Okay, so that is nothing but Q V by 2 pi R or Q omega by 2 pi. After that, we defined current density. Current density means current per unit area. Current density. Current density means J equals to uh, integral J bar dot dA bar. Okay. So from this I equals to j into a cos theta, where j is constant, current density constant. Okay, so thank you everyone. We will discuss about microscopic model of Ohm's law in the next class.